To determine the appropriate grounding conductor size for post lights at the end of a long driveway, let's consider the scenario where the total load is 10 amps at 120 volts, the length of the run is 500 feet, and the voltage drop should be less than 5%. This requires 6 AWG conductors for the line conductors. The question then becomes, what size grounding conductor is required based on a 15 amp breaker, and can 6/2 UF cable be used? Based on a 15 amp breaker, the minimum grounding conductor size required is number 12 AWG. Yes, you can use 6/2 UF cable out to the lights. UF cable is a type of non-metallic underground cable that contains 6 AWG line conductors and a number 12 AWG grounding conductor. This meets the requirements for the grounding conductor and provides sufficient capacity for the 10 amp load. Firstly, let's look at the voltage drop. A 5% voltage drop is equal to 120 volts multiplied by 0.5, which equals 6 volts. The voltage drop per conductor is 6 volts divided by 2, which equals 3 volts. Secondly, the conductor size can be determined using the NEC Table 8, Column 4, for copper conductors at 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. For a voltage drop of 3 volts, a length of 500 feet, and a load of 10 amps, the required conductor size is 6 AWG. Thirdly, let's analyze the grounding conductor size. NEC Section 250.122b requires a grounding conductor not smaller than the conductor used for the supply circuit. Since a 15 amp breaker is used, the grounding conductor must be number 12 AWG or larger. In conclusion, based on the calculations and requirements of the NEC, the following is acceptable for this installation: 6/2 UF cable containing 6 AWG line conductors and a number 12 AWG grounding conductor, and a 15 amp circuit breaker. Let's delve deeper into grounding conductors, voltage drop, and related NEC requirements. Grounding conductors play a vital role in electrical safety. They provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices such as circuit breakers or fuses to quickly trip and clear the fault. This minimizes the risk of electrical shock and equipment damage. The size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installations. It provides comprehensive guidelines for the design, installation, and inspection of electrical systems. Compliance with the NEC is essential to ensure the safety of people and property. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, conductors must be sized appropriately for the load and length of the circuit. The NEC provides guidelines for calculating voltage drop and recommends limiting it to a maximum of 3% for branch circuits and 5% for feeders. UF cable, or underground feeder cable, is a type of non-metallic cable specifically designed for direct burial in the earth. It is resistant to moisture, sunlight, and other environmental factors. UF cable is commonly used for outdoor lighting, underground circuits, and other applications where the cable is exposed to the elements. The 6/2 UF cable mentioned in the answer contains two 6 AWG insulated conductors and a number 12 AWG bare grounding conductor. The two insulated conductors are used for the hot and neutral wires, while the bare conductor serves as the grounding conductor. The NEC specifies the types of wiring methods that are permitted for various applications. UF cable is permitted for direct burial in accordance with NEC Section 340.10. Direct burial means that the cable can be buried directly in the earth without requiring additional protection, such as conduit. However, the cable must be buried at the proper depth, as specified in NEC Table 300.5. The depth of burial depends on the voltage of the circuit and the type of location. For example, a 120-volt circuit in a residential area must be buried at least 12 inches deep. In addition to direct burial, UF cable can also be installed in conduit. Conduit provides additional protection for the cable and allows it to be installed in areas where direct burial is not permitted. The type of conduit used must be suitable for the environment. For example, PVC conduit is commonly used for underground installations because it is resistant to moisture and corrosion. When installing UF cable and conduit, the conduit must be properly supported and secured. The NEC provides guidelines for supporting and securing conduit in NEC section 344.30. The guidelines specify the maximum spacing between supports and the types of supports that are permitted. The NEC also provides guidelines for grounding electrical systems in Article 250. Grounding ensures that all metal parts of the electrical system are connected to the earth, providing a low impedance path for fault current to return to the source. This helps to protect people from electrical shock and prevent equipment damage. The grounding system consists of a grounding electrode, a grounding electrode conductor, and equipment grounding conductors. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth. The grounding electrode conductor connects the grounding electrode to the electrical system. Equipment grounding conductors connect the metal parts of the electrical system to the grounding system. In the case of the post lights at the end of the lawn driveway, the equipment grounding conductor would be the number 12 AWG bare conductor in the 6/2 UF cable. This conductor would connect the metal parts of the light fixtures to the grounding system, providing a path for fault current to return to the source. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. In this case, the overcurrent protective device is a 15 amp circuit breaker, so the minimum size of the equipment grounding conductor is number 14 AWG. However, the 6/2 UF cable already contains a number 12 AWG grounding conductor, which is larger than the minimum required size. Therefore, the 6/2 UF cable is suitable for this application. When installing the post lights, it is important to follow all applicable codes and regulations. This includes the NEC, as well as any local codes or ordinances. It is also important to obtain the necessary permits before starting the work. Electrical work can be dangerous, so it is important to take precautions to protect yourself from electrical shock. This includes wearing appropriate personal protective equipment, such as rubber gloves and safety glasses. It is also important to energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse. Before working on any electrical equipment, it is important to verify that the circuit is energized using a voltage tester. A voltage tester is a device that detects the presence of voltage in a circuit. If the voltage tester indicates that the circuit is still energized, do not work on it. Contact a qualified electrician to energize the circuit. When working with electrical wiring, it is important to use the proper tools and techniques. This includes using wire strippers to remove insulation from the wires and using wire connectors to connect the wires together. It is also important to make sure that the connections are tight and secure. Loose connections can cause overheating and electrical fires. After completing the electrical work, it is important to test the circuit to make sure that it is working properly. This can be done using a multimeter. A multimeter is a device that measures voltage, current, and resistance. If the circuit is not working properly, troubleshoot the problem and make the necessary repairs. Here are some additional considerations for installing post lights at the end of a lawn driveway. Firstly, consider the location of the post lights. The post lights should be located in a place where they will provide adequate illumination without causing glare or obstructing traffic. Secondly, consider the type of post lights to use. There are many different types of post lights available, so choose a type that is appropriate for the style of your home and the surrounding landscape. Thirdly, consider the wiring method to use. UF cable is a common wiring method for post lights, but other wiring methods may also be suitable. Fourthly, consider the overcurrent protection to use. A 15 amp circuit breaker is a common choice for post lights, but other overcurrent protection devices may also be suitable. Fifthly, consider the grounding method to use. The grounding method should comply with the NEC and any local codes or ordinances. Sixthly, consider the voltage drop. The voltage drop should be limited to a maximum of 3% for branch circuits and 5% for feeders. Seventhly, consider the environmental conditions. The post light should be suitable for the environmental conditions in your area, such as temperature, humidity, and exposure to sunlight. Eighthly, consider the maintenance requirements. The post light should be easy to maintain and repair. Ninthly, consider the cost. The cost of the post lights and the installation should be within your budget. Tenthly, consider the safety. The post light should be installed in a safe manner to protect people from electrical shock and prevent equipment damage. By following these guidelines, you can ensure that the post lights at the end of your lawn driveway are installed safely and properly. Remember to consult with a qualified electrician if you have any questions or concerns. In summary, determining the correct grounding conductor size for outdoor post lights involves several steps, including calculating voltage drop, selecting the appropriate conductor size based on the NEC, and ensuring compliance with all applicable codes and regulations. Using 6/2 UF cable with 6 AWG conductors and a number 12 AWG grounding conductor, along with a 15 amp circuit breaker, is a suitable solution for this application, provided that all installation guidelines are followed. Prioritize safety and consult with a qualified electrician to ensure a successful and code-compliant installation. The NEC serves as the cornerstone for electrical installations. Understanding its requirements ensures the safety and efficiency of electrical systems. The grounding conductor's role is paramount in safeguarding against electrical hazards. Proper sizing, adhering to NEC guidelines, is not just a recommendation, it's a necessity. Voltage drop, often overlooked, can significantly impact the performance and lifespan of electrical equipment. Calculations and appropriate conductor selection are crucial to mitigating these effects. UF cable offers a reliable solution for underground electrical applications. Its durability and resistance to environmental factors make it a preferred choice for outdoor lighting and power distribution. However, it is important to consider the ampacity of the conductors. Ampacity refers to the current carrying capacity of a conductor. The ampacity of a conductor depends on its size, material, and insulation type. The NEC provides tables that list the ampacity of various conductors. It is important to select conductors with an ampacity that is sufficient for the load. If the conductors are undersized, they can overheat and cause a fire. Furthermore, consider the ambient temperature. The ampacity of a conductor is affected by the ambient temperature. The higher the ambient temperature, the lower the ampacity of the conductor. The NEC provides correction factors for adjusting the ampacity of conductors based on the ambient temperature. Also consider the number of conductors in a raceway or cable. The ampacity of conductors is also affected by the number of conductors in a raceway or cable. The more conductors in a raceway or cable, the lower the ampacity of each conductor. The NEC provides adjustment factors for adjusting the ampacity of conductors based on the number of conductors in a raceway or cable. In addition to these considerations, it is also important to follow all applicable codes and regulations. This includes the NEC, as well as any local codes or ordinances. Electrical work can be dangerous, so it is important to take precautions to protect yourself from electrical shock. This includes wearing appropriate personal protective equipment such as rubber gloves and safety glasses. It is also important to energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse. Before working on any electrical equipment, it is important to verify that the circuit is energized using a voltage tester. A voltage tester is a device that detects the presence of voltage in a circuit. If the voltage tester indicates that the circuit is still energized, do not work on it. Contact a qualified electrician to de-energize the circuit. When working with electrical wiring, it is important to use the proper tools and techniques. This includes using wire strippers to remove insulation from the wires and using wire connectors to connect the wires together. It is also important to make sure that the connections are tight and secure. Loose connections can cause overheating and electrical fires. After completing the electrical work, it is important to test the circuit to make sure that it is working properly. This can be done using a multimeter. A multimeter is a device that measures voltage, current, and resistance. If the circuit is not working properly, troubleshoot the problem and make the necessary repairs. Proper planning and adherence to safety protocols are essential for any electrical installation. A thorough understanding of the NEC and its guidelines is crucial for ensuring a safe and code-compliant system. Consulting with a qualified electrician can provide valuable insights and expertise, helping to navigate complex electrical challenges and ensure the safety and longevity of the installation.